Okay, here's a question from the homework questions. These are the homework problems that are separate from the chapter for chapter 1. And in this question, which is H151 and H152, they're asking about these SO4 structures and assigning the charges, and then giving the average charge for the resonance hybrid. And then question 52 asks what the average bond order for the SO2 bond is. And so that's going to be basically a numerical value that we would assign as the average for all of the bonds. So let's go ahead and look at how we would solve this problem. So the first thing we need to do is assign all the formal charges of the sulfurs and the oxygens in this system. So sulfur, of course, has 6 valence electrons, as does oxygen. So basically what we can know about this is anytime you have an oxygen with 3 lone pairs in a single bond, it will have a -1 formal charge. And anytime an oxygen has a double bond and a lone pair, it will have a 0 formal charge. And that's because in the first case, oxygen comes with 6 electrons as a neutral atom. It owns 1, 2, 3, 4, 5, 6 electrons in the lone pairs outright, and it owns 1 in the bond, so now it owns 7. It came with 6, so it's -1. For the double bonded oxygen, it owns 4 electrons outright, and then 1 in each of the 2 bonds, so it owns a grand total of 6. It came with 6, it owns 6, so there was no loss of electrons. So in the first case, we gained an electron to go to -1, and we didn't gain or lose anything with the oxygen double bond. Now looking at the sulfurs here, each one of these sulfurs, it owns 1 in each of the 2 single bonds, 1, 2, then 3, 4, 5, and 6. So sulfur is automatically going to have a 0 formal charge in all of these resonance structures. So if we go through and we assign formal charges, all of the oxygens with the single bond and 3 lone pairs are all going to have -1 charges, and all of the double bonded oxygens are just going to have a 0 formal charge. So we can go through here and we can assign all of these oxygens as having a -1 formal charge. Okay. Now if I was looking at the resonance, writing the resonance hybrid structure, which I will do over here, I'm going to average bonds and charges. Let's start with charges. So looking at the top oxygen, it is 0, it is 0, -1, -1, -1, 0, and 0. So by my count, that's 3 -1s and 3 zeros. So you could make the case that this is -1/2. We would call this delta minus if we're not interested in the exact charge. And for all these oxygens, you're going to have 3 -1s and 3 zeros. So if we look at the second one here, -1, 0, -1, 0, 0, -1. So all 3 of these, or all 4 of these oxygens are going to have -1/2 charges, and again, we could call those delta minus. But in this case, I suspect the problem wants an exact numerical value. Remember, this is SO4 2 minus a sulfate ion, so the -1/2 spread out over 4 carbons is -2. Okay, as far as bonds go, we're going to end up with 3 going to the top carbon, 1, 1, 2, 3 double bonds, and 1, 2, 3 single bonds. So that's going to be the case in all of the sulfur-oxygen bonds. we're going to end up with a partial double bond. But in this case, since all 6 of these structures have the same energy, you could basically put a numerical value on these bonds so that each one of these bonds is basically 1.5. In other words, it's perfectly in between a single and a double bond because you've got 3 doubles and 3 singles for each of the bonds. So down here when it says what's the average bond order for the SO bond, it would be 1.5. So in this problem they're looking for an exact numerical answer. And so the charges on the sulfurs would the charges on the oxygens would each be -0.5, and then for the bonds to the SO bonds, they would each be exactly a bond and a half.